Welcome, everybody. This is a series of webinars or video interviews, let's say, that we're doing with various companies in the industry. You may have seen some previously, and it's generally about some of the award winners of the British Hydromet Awards we did last year. Today we're here with Raymetrics, and I want to introduce Stratis and be introducing himself further in a moment. But we've they won an award for the best Lidar application in meteorology last year. Yeah, this is a company that we've known for many years, and we've always admired their technical innovation and how they go by their work. And the reputation of this company is phenomenal. So this is an opportunity for us to deep dive a little bit into some of the background of Raymetrics, some of the applications, and really get to know them. So Stratis, let's start. Do you mind introducing yourself and who you are, and then let's we'll get into it. Thanks for coming.
Yes, absolutely. Look, thanks. Yes, my name is Stratis Hatzistefanis. I am a board member of Raymetrics. I'm also one of the original shareholders of the company. And it's a company that has a long history. We started in 2002, but we're going to get into this when we progress with the interview.
Absolutely.
Yeah. Look, yes, go ahead.
Thanks. Yeah, look, I just wanted to touch on the award to start with. I know that these things are well earned, and we like to think have a good impact on not only you as a company, but on the recognition of what you guys do. How was that for you guys as an achievement to receive that award?
Yeah, so first of all, we're very proud for receiving that award. It was, I think, our first major international award that we've ever won. So that was a proud achievement for us, and it was a major recognition because it recognized many years of scientific work and innovation in meteorology and climate monitoring. And we are very much an R&D based company, so that was a very proud moment for us, and especially for our scientific staff as well.
Yeah, no, that's great. Again, I think it's well deserved. But let's have a dive into why you got the award and how we got to today. So you mentioned 2002. Do you want to give us a little bit of that backstory? Is that okay?
Yeah. So I mean, the company started 2002, and it was a very interesting story because it was a research project out of the Technical University in Athens. So we're a Greek company. I don't know if we said that at the beginning, but we are a Greek company based in Athens. All our operations are in Athens. And so it was a spin-out from the university. And in fact, the professor whose research work established the company is still our CTO.
Okay.
Professor Yoroussis, yeah. And him and his PhD students were the only two people working in the company. They were manufacturing bespoke system exclusively, I have to say, for research purposes. And that PhD student now is our head of production. So we tend to value continuity. Let's say that, right?
Yeah.
Yes. So that's how it started. And then, of course, we've moved on quite a lot, and we'll get into it later on, I think. Yes, but we're very proud of our heritage, and we're very proud of achieving that because, it's very, very difficult, especially in a country like Greece that does not have the pedigree of spin-outs, and it's not an industry that the universities really focus on. It's one of the very, very few stories like that.
Yeah, no, that's interesting. I think some of the best technology companies are born that way, aren't they? But as you say, Greece isn't necessarily known for that. But where's Raymetrics today then? So you're talking 24 years this year, looks like. What is your main work of Raymetrics today? Who are you serving? Who are your users? What does the company look like now?
I mean, if we stick to meteorology, we now work. I think we're in over 40 countries across the world, providing meteorological and climate services in general. to most of the well-recognized Met offices around the world. The UK Met Office, for example, is one of our leading clients. And we provide different services. Obviously, the main focus is data that is used for forecasting. But because LiDAR has the additional ability to provide real-time data and critical data very quickly, that's very crucial also for early warning systems. And one of the industries that we've branched out, very closely related, obviously, is aviation and climate monitoring. So we do a lot of that, and we also recently, moving away from government agencies, we also do pollution monitoring for commercial flights.
Wow. Okay, so yeah, I think it's I would imagine that the applications of it are almost infinite, really. How it's you could be sector to sector, industry to industry. It could be an endless potential.
Yes. So one of the things that we try to do a lot, and we've been fairly successful, I think, doing it, is taking our core LiDAR technology and applying it to different industries. So if we go to where we are now, I mean, when we began, as I said in the beginning, it was really a research project. And all the systems that were produced, and I would say for the first probably 5 to 6 years of the life of the company, were bespoke systems for research institutes. That's it. Researching, atmospheric changes, aerosols in the atmosphere, particles, pollution. And if you look at those systems, they could only really be operated by PhD students and engineers, right? There was no UX, the software was very basic. People were writing their own software, actually, to use it for the purpose that they wanted. Where we are now, we have a whole floor of software engineers, because that's, if we're selling to commercial entities, the user is not the same, right? So that's how the company has matured. But we have now, I have to say, I think we have 3 very specific pillars that we operate on. One is our core pillar, which is meteorology. That is really what you guys gave us the award for, and we're most well known for, and we can drill into it. Our next pillar is civil protection, as we call it, and that's critical early warning, with whether it's pollution or our latest product, which is wildfire detection. It's very important for Greece, but also for the whole of Southern Europe and California and Australia. And our third pillar, very, very recently, is defense. And what we have, as we're very early, very new entrant in defense, but we managed to get a very, very important award. We became a NATO technology partner. We've won a NATO Diana competition to develop a small drone detection system on the basis that LiDAR laser technology in general is the one that can actually identify very, very small, the class 1 drones that you see in Ukraine. But in essence, it is the same technology. In principle, it is the same technology.
Yeah, I think that's why Raymetrics is admired, really, is how you find these use cases for it. And yeah, I mean, that's hugely important. Going back to meteorology, can you sort of explain in simple terms how LiDAR is applied to meteorology? Like how does it work in that space? That'd be great to know.
Yeah, so I mean, the unique advantage of LiDAR technology is that it allows the user to observe the atmosphere in 3 dimensions and in real time. So that is very important. So you get very detailed information about clouds, aerosols, dust, fog, any particles really, any particles, and air movements, which is very important. So you can measure wind speed, wind shear at different heights, at different altitudes. And you have quite a wide azimuth as well, which is also very important. Now, the other major advantage of LiDAR is, of course, you can go very high, but you can also go very low. And so you can measure all these things at a very low altitude, very close to the ground as well. So, and it's real time. So that level of detail is crucial now for forecasting and aviation, as we said before, which is very closely related to meteorology and climate services. So I think that's the unique advantage of LiDAR versus traditional meteorological measurement techniques.
Yeah, I suppose it's that level of detail. I guess it's particularly around, critical infrastructure, as you say, aviation. I suppose perhaps they wouldn't want to sort of cover every inch of the country with this, but it's certain, protecting certain spaces, certain, where would they maybe outside of aviation, where would they typically be placed? Would it
Well,
be
no, I mean, listen, so the UK is a very good example. The
yeah.
UK Met Office operates 10 stationary LiDAR posts, let's put it that way. And they use our systems. And they're placed from the Outer Hebrides all the way to Exeter.
Okay.
Right? 10 of them. And they also have a mobile unit. That's the 11th unit in a van, so they can move it wherever they want. The UK started this project for a very specific reason. They started it. Do you remember the Icelandic volcanic eruption? I think you probably were very young. But I had a lot of friends that got stuck in God knows where because they couldn't get back. The whole airspace was closed, right?
Yeah.
And the reason it was closed, it was because there are many different ways to see the dust cloud or the volcanic ash cloud. You could see it from satellites. But what you couldn't see from satellites is the density. And you couldn't see the density in different altitudes. So if you remember what happened at that time, they closed the whole UK airspace for days. It was almost a week, if you remember.
Yeah.
The disruption was huge. And that cost the aviation market in the airports a lot of money. That was the impetus for the UK Met Office to get quite a lot of money to invest and find a solution to that. And the solution they found is LiDAR. Because LiDAR can give you, from the ground, the information that no other technology can give you, which is particles, volcanic ash in this case, what is the concentration at different altitudes? And therefore, can airplanes safely sail through? Fly through. Sorry, not sail.
That's great. That's a great example, I think, actually. I think that's that use case and the fact that, that's how your relationship with the UK Met Office was established.
That's how it started.
You solved a very specific problem there.
It was very specific. And what happens next, and that's a very sort of common thread in our relationship with the clients that we have, is that they start with that. So we want to have a solution for volcanic ash. Okay. But they quickly realize that they can use LiDAR to measure moisture content, which helps them in their weather, in their general weather prediction, right? Wind speed. So that's just adding different channels to the same system.
Yeah, makes sense. That leads me on to that leads me on to another question here I had was about the meteorological needs of different countries, particularly let's say different regions, particularly. You might be looking at the Caribbean and they might be, tropical cyclones, or, you might be looking at the Middle East and there might be issues with sand and dust, and then the pollution in cities. And, how do you guys handle that? And, what do you offer in terms of services for like the different needs in that way?
So a good example that we recently installed some systems in Saudi Arabia and in Dubai as well. Now, their biggest problem is dust. from the desert.
Yeah.
That's what impacts visibility there. It's not fog usually or extreme cloud conditions. It's dust. So that's what they want to monitor more so than anything else. As you said, in the Caribbean, it will be moisture because of cyclones and winds, right? So yes, so that's what we do. And depending on the region and what the needs of the partner that we're working with,
Yeah.
we change the specifications of the systems that they buy. Precisely.
Makes sense.
Yeah.
You can be customized to the need to the system. That's great. I think we're seeing that as a trend that is more and more required now. Just to sort of trim off that waste. It's like, what do you need exactly, and what is going to get you from A to B.
Exactly.
Yeah.
Because also think about it. You wouldn't want to buy a system, and
No.
you won't buy one because obviously you want to have a network, right? If you want to buy a system that will measure absolutely everything under the sun, it will be very expensive, and you probably won't need it. So each country, each region wants to focus on the things that they actually want to do and want to measure.
Absolutely. This brings me nicely on to the next point. Actually, is around data. So how typically is the data used? I guess I suppose I'll talk about weather services and meteorological agencies specifically. Like, and what ways do they tend to use the data that's collected? For forecasts and models and so forth.
So the data is used for forecasting, mainly in terms of the Met Office usage. It's just another data point from all the data points that they measure and they use from other sources. The UK Met Office, has a lot of sea-based buoys that they measure different sea conditions and temperature and speeds of currents. So that's another data set. So these atmospheric data sets that they get from lidars, they use other atmospheric systems, satellites as well. So this goes all into the mix for their forecasting. But also, if you move away from strictly meteorological, the Met agencies, and you look at aviation is more about early warning, visibility. So one good example there is airports. The traditional visibility measurements for airports has been sailometers.
Yeah.
Which I'm sure you've seen them. Yeah. Everywhere. Sailometers are, I think, a 1950s technology.
Yeah, I think so.
Yeah. So all that the sailometers do is they shoot vertical beam and they measure the first cloud cover. Okay. Now that's good enough. And all the airports and all the aviation agencies across the world have the rules of spacing aircraft based on cloud cover, in fact. And cloud cover is the best measurement that we've had so far to estimate visibility. Obviously, the true visibility is not going to be the same, but there's a good benchmark. And it's safety, so no one has really challenged that. So if you go to a capacity-constrained airport, like Heathrow is a great example. Heathrow operates a cycle which is, I have to tell you now, I can't remember the exact cycle, but I think, I'm going to say 90 seconds, could be even less than that, between each aircraft movement, takeoff or landing, right? And they are, last time I went to see them, they are operating at full capacity 365 days of the year. Now, if you ask them on how many days they actually achieve full capacity, I'm sure they will understand that it will be very few, right? So if their sailometers give them a cloud cover that triggers a spacing, that 90 seconds goes over to 2 minutes because they have to observe some safety protocols, right? Using LiDAR gives you actual slanted visibility measurements, i.e. what the pilots see as they approach,
Yeah,
which would be
exactly.
very, very different from what the vertical sailometer cloud cover visibility is. So that can give you the ability to actually not to have to space out as much.
Yeah,
That's
that
the
makes sense.
and that's a real-time measurement, right? It's not a
Definitely.
forecasting measurement. That's a
And
real
every second saved or wasted, is
exactly.
you can do the maths on that pretty easily, right?
Exactly. So that's a use case, and we've done that. We've come up with this project, and we have installed it in a few international airports. And there's been a lot of there's been a huge change. That's a big change for the airports, but it's actually a very slow adoption cycle. Because think
Yeah,
about it, you have so much ingrained resistance to changing this type of
for sure,
property.
for sure.
Yeah.
No, that's interesting. That's really interesting. I think one of the last points from me then is just looking into the future. Beyond meteorology, there's obviously other applications as we've spoken about. What are the goals for the future, especially in sort of AI and general innovation? What's next for Raymetrics? I
Yes.
guess that's my first of the last two questions, and the second one would be, if people wanted to then engage with you guys, like what's the best starting point? So
Yeah.
let's talk about the future of Raymetrics and then how people can engage with you.
I think in terms of future, especially when it comes to meteorology and climate change, uh, data is the most important commodity here. Now, I have to say we haven't been very good at it, and that's something we need to improve. And I think the Met offices around the world are not very good at it either, in a sense that they all keep their own data.
Yeah.
And they really, very close to their chests, right? But in reality, what we've seen and we're continuously seeing is that it is really a global phenomenon, and they're very interrelated. Um, and we have built our systems to be really standalone. And I think one of the future developments for Raymetrics should be to create a community of data.
Mm-hmm. Mm-hmm.
Because really, our different systems around the world collect so much data that can be the multiplier effect will be huge if it can be combined and people can use them across the board. And I think this is something that we want to invest in and create, a web application where people can see multiple sources of data from different regions. So and AI, of course, can help a lot in analyzing that data.
Absolutely.
Yeah, so we want to do that. And I think that would be a major breakthrough. And it will be very useful for even people that don't use
Mm. Yeah, it's true.
light.
Interesting.
So that's, I think, one software-related innovation that we really need to push forward. For Raymetrics, more specifically, obviously, we want to advance our industrial applications and not just rely on Met offices. That one of the problems with Met offices is that they're government agencies.
Mm.
So their decision-making cycles are, let's put
Yeah.
them mildly, rather slow, right? Yeah.
Sure. Yeah. Of course. Yeah.
So we want to focus also on our corporate applications. I think that's important for the health of our company. Right?
That's perfect.
And defense, obviously, now in Europe is a very, very big focus.
Yeah.
And that's something we want to invest in. How to engage with us? Listen, I think we're easy to find. We have our website. We have a lot of installed bases around the world. We typically have, for some countries, we have a local representative.
Yeah.
But people should, engage with us directly. If you go on their website and log a request, you'll get an answer immediately.
Yeah. Also, if anyone watching can't find that,
www.raymetrics.com. Yeah.
Yeah, exactly. Or if you want us to put in touch, we'll connect everybody up there. So, well, look, we've always been, we haven't worked loads and loads with Raymetrics, but more and more so at the moment. And we've always admired what you do as a company, and you're always there and visible at the shows in Europe and everything, and it's great. We'd recommend anybody to get in touch about this. And we look forward to working more in the future. But look, before we wrap up, Stratis, thank you for your time. Really appreciate that, and I think you've given a really good overview there of the key points. But is there anything else you want to say before we end there?
No, I think we covered a lot of it.
Yeah.
I'm very excited about this and the opportunity. Thank you.